Testing 1 2 testing. So lesson 6.2 starts with talking about some very important business-like math terms. Starting with compound interest. Anytime you get a mortgage or anything like that, it's calculated using compound interest, and this is interest that is calculated on both the principal and previously earned interest. Now, this compound interest can grow, right, very quickly. So when you talk about investing at a young age, compound interest is what makes your money grow pretty fast. So we also have exponential. So compound interest is based off an exponential function, right? And an exponential function is a function that has the form, right? And I'm going to write this in. That form is f of x equals a times b to the x, where a is a constant, right? And the base b is a positive but not equal to 1, and the exponent x is a number, right? We call a basically the initial amount, and we call b, right, the rate of growth. All right, and with this, x represents any number, okay? So when we talk about exponential decay, right, it's a situation where the quantity decreases by a common ratio at regular intervals. So with this, your b value tends to be between, right, 0 and 1. So it's definitely less than 1, but greater than 0, meaning it's not negative. All right. So what happens is when we look at this graph, exponential decrease means you start with an amount and it decreases very quickly. Exponential growth is a situation in which a quantity increases real quickly at regular intervals. So this basically starts out small and grows very quickly, right? And that is something as b values greater than 1. Okay? So the principal, all right, is the amount of money invested or borrowed. So that is your P, all right? P can be your principal or your initial amount. Either way you want to look at it. All right? So now that we have this, okay, the main idea is to understand that the function f of x, so the key here to know is that f of x equals a times b to the x, where a is going to be a number, right, and that's your initial amount, right? B will be a number, and that is your rate of growth. Okay, so x will be your input value, and that'll generally be like years and stuff like that. It'll relate to time with these type of problems. Okay, so here if we had to fill in the descriptions, right, when we talk about exponential growth is an amount that increases, right, exponentially at a constant rate of time. Okay, and when we talk about the rate of time, right, an example of this would be like you're doubling. Okay, so something is doubling every year, or something's like tripling every year. That would be an example of a constant rate. When we talk about exponential decay, an amount decreases, right, exponentially. And when we talk about an example of this type of rate, it would be something like half-life. Okay, so we look at this example down here, right? This represents exponential growth, and I can see this is exponential growth right away just because that letter B, the base B, is 3, and that's greater than 1. Okay, so looking at this, if I had to evaluate this function, f of 4, that would be equal to 3 to the third, or sorry, 3 to the fourth. Everywhere I see an x, I'm replacing with 4. So f of 4 is equal to 3 times 3 times 3 times 3, which ends up being 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. So f of 4 is 81. Now, you can easily use your calculator for that also, if you wanted to, right? If you have a graphing calculator, you would just put 3 caret key 4 in, and it would give you the answer. Alright, f of 3 now, where it's exponential decay, and I'm going to give you the function here is f of x equals 2 times 1/2 to the x power. Now, if I gave you this function and I told you this was exponential decay, the reason I know is your base b is a number between 0 and 1. Alright? Because it's less than 1, that tells me it's exponential decay. So the amount you're starting with is 2. So when I go to evaluate f of 3, it's 2 times 1/2 to the third power. Okay? And if I go to figure this out, 2 times 1/2, times 1/2 times 1/2 will give me 2 times 1 times 1 times 1 is 2. 2 times 2 times 2 is 8. This would reduce to 1/4. So if you notice, if you started with an amount of 2, right, and it was decaying at a rate of 1/2 or a half-life, after say 3 minutes, 3 years, whatever it is, you would be left with 1/4. So your amount is less than what you started with. Okay? So now, here, in this function, right, so in the function, f of x equals 3 to the x is the input, right, and f of x is the output. So basically here, when we look at this, if they tell us the function has a value of 81, right, what would the value of x have to be? Well, when I look at this, if f of x equals 81, we're basically saying 3 to what power is equal to 81? Well, I know 3 to the first power is 3, 3 to the second power is 9, 3 to the third power, if I multiply 9 by 3 would be 27. 3 to the fourth power would be 27 times 3 is 81. So in this case, x would equal 4. Because, right, the way we check it is 3 to the fourth equal to 81? Yes. So the value of x that makes that equal 81 is 4. Alright. Now, in this, again, in the general form of an exponential growth function, a represents the initial amount, right? B represents the growth factor. And for an exponential growth function with a greater than 0, b must be greater than 1. Okay? Now, in a general form for an exponential decay function, right, as this, a represents the initial amount again. B represents the decay factor. And for an exponential decay function with a greater than 0, meaning your initial amount is greater than 0, b must be between 0 and 1. Okay? So, right here, if we look at this, right, example 1, if you're given 20, right, a decay initial amount of, your initial value is 20, the growth or decay factor is 3, this tells us its growth. The function here would be f of x equals your initial amount, 20, times, what is your growth factor? 3 to the x power, right? And we said, because your growth factor is greater than 1, right? That tells us it is growth because the growth factor is 3. Okay? Now, if I told you the initial value of the next function was 15, and I told you the growth or decay factor was 3/4, what would our function be here? Well, f of x equals, what's our initial amount? 15. What is our growth or decay factor? 3/4 raised to the x power. Now, because our growth or decay factor is less than 1 but greater than 0, we would say that this is exponential decay because, right, 3/4 is less than 1. Okay? So now compound interest, right? In compound interest, right, we see this as an exponential growth function, right? And in the compound interest formula, right, you get a of t equals p plus, or times 1 plus I to the t, where a of t is your amount, right? Actually, they have it right here, so I'm going to go here. This is the amount, right, of money in the account after t years. P represents the principal. This is the amount you start with. Okay? Now, I represents interest, all right, and its interest rate. And generally, this will be as a percentage, all right, but we have to write this as a decimal when we put it in. Okay? And T represents the number of years the interest is compounded. Okay? So this formula is pretty easy to use. Once we get through a couple of examples, you'll understand. So here it says, you invest $200 in a savings account, right? That pays 3% interest compounded annually, meaning each year, right? It compounds, you earn interest each year, and then that money grows. How much money is in the account after 8 years? Well, what's our principal or starting amount? That would be $200. Our rate is 3%, but when we use this in the formula, we're going to use it as 0.03. To change a percent to a decimal, we take the percent, divide it by 100, you get 0.03. And the time in this case is 8 years. Now when we go and calculate this, right, you put it in the calculator exactly the way you see it. So the amount after t years, which is 8, is 200 times 1 plus 0.03 raised to the 8th power. Now, what I do in this case, so what I basically do is I plug this in the way I see it. So I'm going to go 200, I'm going to open the parentheses, I'm going to say 1 plus 0.03, close parentheses, then I'm going to raise it to the 8th power, right? And now, what happens is, if you see that amount, this is the amount that you'll have in. So it would be the amount after 8 years would be $253.35. Okay, so what they're basically telling you is just for putting money in the bank, if you put $200 in a bank and it's getting 3% interest compounded annually, right? You would have $253.35. So you made $53 for doing nothing. Okay, let's take a look at these examples below. Right? Find f of 3 for the function below. So f of 3, I'm going to plug 3 in for x, right? And if I go to my calculator, I can look at this one of two ways. If I do it by hand, That would be 4 times 4 times 4. 4 times 4 is 16 times 4 would give me f of 3 is 64. Okay, now if I do it in the calculator, I would just go 4, caret key, and then 3, hit enter, and I would get 64. Now the next one, to find f of 2 for this function, f of 2 equals 1/8 times 5 to the second power, which is basically going to give me 1/8 times 25. So f of 2 would equal 25 over 8. There's two ways you can look at it. If I go open parentheses 1 divided by 8, that's how you put a fraction in, times 5 to the second power, it would give me 3.125. Okay, f of negative 2 for the next one, f of x equals 9 times 1/5 to the negative 2. It's much easier to just go and put this in the calculator. So if I go 9 times, open parentheses, 1 divided by 5, close parentheses, right? And I'm going to go to the negative 2 power, right? That would give me f of negative 2 would be 225. Now the last one, f of x equals 1/2 times, we're going to say 2 to the 7th power. So again, that's the same as 1/2 times 2 times 2 times 2 times 2 times 2 times 2 times 2, right? Now when I multiply these together, just look at this, right? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. So 1/2 times 128 gives me 128 over 2, which is 64. So f of 7 here would be 64. Or I could just put this in as 1 divided by 2, right, times 2, caret key 7, and I would get 64. All right. Now the next one, what is x? What would x have to be for 4 to the x to equal 64? Well, right away if I go 4 to the first power, that's 4. 4 to the second power is 4 times 4, which is 16. 4 to the third power is 4 times 4 times 4, which is the same as 16 times 4, which is 64. So what would x have to be in order for 4 to the x to be equal to 64? X would be 3. Okay. Next one. The population of a town can be molded by f of x equals 17,200 times 1.1 to the x. What is the initial value of the population? Right? The initial population is 17,200. Right? This is your initial population. Right? Now, is the population increasing or decreasing? When I look at my base b, is that less than 1 or greater than 1? My base b is 1.1, and that is greater than 1. Then I know the population is increasing because that is exponential growth. Right? So this is growth. And how does the population change each year? Right? For me, I can recognize that it grows 10% each year. And the reason is, when you look at the compound interest formula, right, your rate of growth is 1 plus the rate. And if this ends up being 1.1, that would be the same as 1.1, which means this is 10%. Okay? So another way to kind of look at that, if you're trying to figure it out, remember it's a times 1 plus your interest rate, which they put as I, right? So once you know this to figure out what it grows or decays by, right? If it's growth, right, you're going to basically do 1.1 subtract 1. That gives you 0.1. That's a percent as a decimal. To figure out the percent then, take that decimal, multiply it by 100, and you would get 10%. All right. Number 7, the population of a town is modeled by f of x equals 19,820. Identify the initial value, right? The initial value is 19,820, right? Now your population is decreasing now. How do I know that? Because this number here is less than 1. So my growth or decay factor, in this case decay factor, is 0.98. So when they ask how the population changes each year, right, what I have to notice is I know it's decreasing, but by how much? Well, if 1 minus the rate, meaning the percent, is equal to 0.98, hypothetically, if I go and solve for r, I would get negative r equals negative 0.02, and when I divide by negative 1, my rate would be 0.02. All right. Now that would be as a decimal, so I have to multiply that by 100 to get 2%. Now we said it was decaying. We said it was decay, so we know it's decreasing. It's decreasing 2% per year. Okay, so it's important to be able to do that. Number 8, use a general formula for an exponential function to write specific function given the initial value is 61 and your growth factor is 3.5. So all I'm going to do is take my initial value a, which is 61, and multiply it by 3.5 raised to the x power. It says here, use the general formula for an exponential function to write a specific function given an initial value of 3, decay factor of 2/3. So f of x equals initial value 3 times 2/3 to the x power. All right. And how much would $400 invested at 5% interest compounded annually be worth after 6 years? Well, f of 6 equals my initial amount at 400 times 1 plus 5% is a decimal, is 5 divided by 100, which is 0.05. And we're raising it to 6 years. So f of 6 would equal, go to my handy dandy calculator, right? And I plug it in exactly the way I see it. 400 times parentheses 1.05, close parentheses 2, the 6th power. That money would grow to an amount of, what do we say, $536.04. $536.04. All right, go ahead, do the quiz. Let me know when you're done, and I'll make the next video.